This is basically an introduction to how we prove similarity and how we prove congruency, but today we're going to focus on the similarity, and at a later stage we'll do the congruency. So if I speak about shapes that are similar, so if I take this triangle, for instance, and I draw another one like this, and I say to you that these two shapes are similar. In geometry, what we mean by similar is that these two shapes are similar in the sense that their angles are exactly the same. So this angle would equal this angle would be equal to this angle, and this angle would equal to this angle. The only difference between these two triangles, as you can see with the one, is the one is smaller than the other. So if I say to you that this side is 2, this side is 4, and this side is 3, this side is 6, and this side is 4, and this side will be 8, then we can see that all I've done is taken this small triangle and I've doubled the sides to get the bigger triangle. So all the angles are the same. The only difference between these two triangles is that their sides are in the same proportion, but it's doubled. So if you think about your school shoes, for instance, if we look at two people's school shoes, they are exactly the same. The only difference is one might be bigger than the other. So with similarity, for two shapes to be similar, we've got two conditions. So basically what this is saying is these shapes can only be similar if the following two things are true. Okay, the first one is that the corresponding sides, not sides, sorry, angles are equal. So like the example above, I say to you that this angle, so let's do another. This angle over here in the smaller triangle is equal to this angle in the bigger triangle. This angle in the smaller one is equal to this one in the bigger one, and this one in the smaller one is equal to this one in the bigger one. So corresponding means the one angle in the one shape not in proportion, but relating to the other shape. Okay. Then the second condition, so the second thing that needs to be true for two shapes to be similar is that the ratios of the corresponding sides must be in the same proportion. Okay, so basically what this means is if I look at this smaller triangle that I had here and I compared it to this bigger triangle, so corresponding sides, so if I'm looking at this side on the left, then I'm looking at this side on the left for this triangle. Okay, and I can see that from 2 to 4, this has just been multiplied by 2, right? From 3 to 6, it's been multiplied by 2, and from 4 to 8, it's been multiplied by 2. So all the sides must be in the same proportion. And when we speak about the ratios, right, if I take two triangles, let's name them to make it easier. So if I take two triangles, okay, and I name this A, B, and C, and this triangle D, E, and F, okay, then if I look at AB and I use the same sides that I used for the previous one, okay, if I look at the smaller triangle, what I'm saying by the ratio is if I go AB over DE because I'm looking at that relationship. So this is looking at the relationship between AB and DE. So if I look at the ratio of AB and DE, AB is 2 and DE is 4. That's what I gave you. So that is a half, which makes sense because the smaller triangle is half the size of the bigger one. Then I go and I do my other side. So BC over EF. So the relationship between those two sides, and that is 3 over 6, which is also a half. Then I look at the last point, which is a side, which is AC over DF. So that ratio, that relationship between those two corresponding sides, and I get 4 over 8, which is also a half. So the fact that these sides are all same proportion, I can say that these two shapes are similar. Okay, so now we're going to go into, we've understood the concept of similarity. Now I want to go into how to prove it. So there's a specific structure that you use. And let's use an example. So we say, so example 1. And we say prove that triangle ABC is similar, and I'm going to use this symbol here. So if you want to write for yourself, this symbol over here means similar. Okay, we want to prove that triangle ABC is similar to triangle DEF. Okay, and I give you over here. All right. A, B, and C, and then D, E, and F. Okay. Actually, let me just change this around so it makes more sense. Okay. All right. So those two triangles, and the information that I give you is if this is 6, 5, and 3, okay, then the one next to it will be, let's do just 1 second. Let me work this out. This one is 18, 15, and 9. Okay, I say prove that those are similar. So now I know with similarity that I either need to prove that all angles are equal, or I need to prove that sides are in proportion. Okay, the fact that they gave me the side lengths, I'm going to use that second condition. So this is how I structure it. I tell them what triangles I'm working with. So I say in triangle A, B, and C, and triangle D, E, and F. So I tell them first which two triangles I'm going to work with, because sometimes you'll get questions that have more than 2 triangles and you have to be very specific. So we first tell them what triangles we work with. Then I know for the lengths, I need to prove that all 3 corresponding sides are in proportion. So that means I need 3 points here. I need 3 sides that are in proportion. So then I go and have a look. Okay, let's take AB over DE, right? So be very careful if you are working this out, make sure that those sides are corresponding. All right, so then I would say it would be 6 over 18. And if I work out what 6 over 18 is, then I would get 3, 1 over 3, sorry, so third. Okay, so far we're fine. Let's check the second one. So we're going to say, okay, AC over DF. So those corresponding sides, are they in proportion? So I've got 5 over 15, which is also going to be a third. Then I look at that last line, So last side, BC over EF, and I get 3 over 9, which is also a third. So here I've got that all three corresponding sides are in proportion. They've got the same ratio. So then I can say, therefore, triangle ABC is similar to triangle DEF. Okay, and my reason, I always give a reason here. My reason would be sides in proportion. Okay, so that's the first example that I'm going to do. Let's do another one. So let's say example 2. All right, and I say prove triangle ABC and triangle DEF are similar. And I give you okay, these two are 90 degrees. This is 20 degrees. Okay, so I give you that, right? And they say prove that those two are similar. So now I know with similarity, either I have to prove all angles equal, so all corresponding angles are equal, or sides in proportion. So I'm not going to choose the sides in proportion because they don't give me any length. So it's going to be very difficult for me to do so. So what I'm going to do is I'm going to use the angles because they give me 20 degrees and they give me 90. So I'm probably going to prove that those three angles are equal. So let's start. We start our structure. So in triangle, ooh, I didn't label these, but it will be A, B, C, and D, E, F. Okay, so in triangle A, B, C, and triangle D, E, F. Okay, I need to prove that all three angles, corresponding angles, are equal. So I need 3 points. All right, so I first say, okay, I know angle A. So be very careful. If I listed triangle ABC first, I need to work with triangle ABC first. Okay, so you can't say, okay, angle D is equal to angle A because we're saying which triangle comes first. So angle A is equal to angle D, which is equal to 20, and we give a reason. My reason here is that it is given. So if anything is printed, then we can say it's given if we don't have to prove it. So if that's given in the question, in this case it is. Okay, then in my small triangle, let's do angle B. We said angle B is equal to angle F, which is equal to 90. This was also given, right? Okay, now I know, so I need a third angle, so this third angle here. And we can say that angle C is equal to angle E. The reason for this is if I work with this triangle over here, right, I do the interior angles of a triangle. I know E will be 180 minus 20 minus 90 because all my angles in a triangle need to add up to 180. So this is going to be, if I go 180 minus 20 minus 90, I'm going to get 70 degrees. The same works if I use this other triangle, the ABC triangle. If I want to work out angle C, then I take 180, I minus 20, and I minus 90. It's going to be exactly the same. So we can skip this whole equation and we can just say to them, okay, that's going to, C is going to equal to E because remaining angles in a triangle. So we can use that reason. So remember, every point needs a reason. Now I finish up my statement. by saying, therefore, triangle ABC is similar. So we use that symbol again. And now for this one, I need to make sure if I said A first, right, in this one, I need to look what angle is A similar to. It's equal to D, so D will come here. Then I look at B, B is with F, and I look at C, C is with E. So I make sure that if someone reads this, they know exactly which angles are actually equal to each other. Now I need to give a reason for why I said it's similar. So we either give that sides are in proportion or that all corresponding angles are equal. Now in this case, we prove that all corresponding angles are equal. So I'm going to say angle, angle, angle. So AAA stands for those three angles are exactly the same. Okay. All right. I'm going to end there for now. I will film another video that has more complicated examples, but for now you can practice just simple proving.